Welcome. Let's look at an example of determining whether Rolle's theorem applies to a function on a specified interval. In this example, our function is f of x equals sine of 2x, and we're interested on the interval from pi over 6 to pi. So we're going to determine whether Rolle's theorem can be applied, and if it can, find all values c such that f prime at c equals 0. Now, as we go through this process of determining whether Rolle's theorem can be applied, there are some criteria that must be satisfied. The first criteria is that f of x is a continuous function over the closed interval from a to b. So our function is sine of 2x, and the trigonometric function sine is continuous over all real numbers, and as it is continuous over all real numbers, it will certainly be continuous over the interval pi over 6 to pi, including the endpoints pi over 6 and pi. So we will make note of that fact. The second criteria for whether or not Rolle's theorem may be applied is that f of x is differentiable over the open interval from a to b. That is sine of 2x differentiable for all values of x between pi over 6 and pi? Well, the sine function is differentiable over all real numbers, and in this case, sine of 2x will also be differentiable over all real numbers. So certainly it is differentiable over the open interval from pi over 6 to pi. Now, there is a third criteria that must be met before we know whether Rolle's theorem applies, and that is that f at the left endpoint of the interval must equal f at the right endpoint of the interval. So let's go ahead and investigate that. So f at our left endpoint is f at pi over 6. So that would be sine of 2 times pi over 6, which is the same as sine at pi over 3, which is equal to square root of 3 over 2. F at my right endpoint, f at pi, equals, and that's, is sine at 2 times pi, and sine of 2 pi is equal to 0. Notice that f at pi over 6 does not equal f at pi, and that therefore implies that Rolle's theorem does not apply. On this interval. Notice that it is simply this interval. Our function was continuous over the interval, and it was differentiable over the interval, but where we failed the hypothesis for Rolle's theorem is that the function output at the left endpoint did not equal the function output at the right endpoint. I hope you find this helpful.